Hey, it's Mr. Saltano. This video is going to explain what is the mole. So in chemistry, there is something called the mole, and that's what this video is all about. So in order to understand the mole, we first have to understand other quantity words. So for example, if we're talking about two of anything, so two birds, two wolves, two shoes, what do we tend to call that? So we tend to call it a pair or a couple, right? And if you were to say a pair or couple, everyone would know that you're talking about two. What about if you have 12 eggs? So what would you refer that to? You wouldn't just say, oh, go get me 12 eggs, right? You would say, get me a dozen eggs. And when you said get me a dozen, the person would know that you meant 12 because a dozen always means 12, right? Unless we're talking about a baker's dozen, which is 13. But again, that would be something else, right? Another word, so in a score, there are actually 20 of the thing. So when Lincoln said, famously, 7 years ago, he was saying that 4 times 20 plus 7 years ago. Because a score, everyone knows, is to be 20. If you hear the word score, you look it up, it means there's 20 there. All of these are different words that represent certain quantities, right? And no matter when you say the word, people know that that word represents that particular quantity. A mole is the same. But the difference is that a mole's number is a lot more complicated, it feels like. The number that's in a mole is actually 6.02 times 10 to the 23rd. So that's a huge, huge number. That's one of the biggest numbers you've ever had to think of. It's far more than a trillion, for example. It's too big to even really wrap your head around. But so basically, it's very important in chemistry for reasons we'll talk about soon. But so this is how many are in a mole. So a mole of anything. Just to give you an idea of how big that is, 1 mole of sand grains, so little tiny sand grains, if we had a mole of those, that would cover the area of Los Angeles up to a height of 600 meters. So it would cover not only all of Los Angeles, but it would cover it to a height of over a quarter mile. So that is, and it's about 0.35 miles high. So that is a lot, right? That's huge. It's too big to even imagine. But a mole is always 6.02 times 10 to the 23rd. So, just as an example, if we said how many cats are in a dozen, you would say, well, that's 12 cats. If we said how many cats are in a mole, you would say, well, there's 6.02 times 10 to the 23rd cats. If we said how many apples are in a pear of apples, you would say 2 apples, right? If we said how many apples are in a mole of apples, you would say 6.02 times 10 to the 23rd apples, which is a huge amount of apples. I recommend watching the mole song video in order to have a better understanding of how incredibly huge this number is. But the point is that if you have a mole of anything, just like if you had a dozen of anything or a pair of anything, it's always going to be that same number. And that number is always going to be 6.02 times 10 to the 23rd. So it's always going to be that. And that's just what a mole stands for, just that quantity, basically. When we are talking about moles, though, we have to be careful that we use the correct representative particle. So a representative particle is just whatever species of particle you're referring to. So for example, if we're talking about just aluminum, just the element aluminum, then the particles that represent aluminum are atoms of aluminum. If we're talking about the molecule nitrogen as in nitrogen gas, the particles that represent that are molecules. They're not just atoms. Nitrogen gas is a joined molecule of N2. Water is a molecule, right? Water is H2O. That's its representative particle. If you break those pieces up, it's no longer water. And then we also use things like ions, which are charged particles, and formula units, which is just an ionic compound, right? So when we say we have a mole of any of these things, we have 6.02 times 10 to the 23rd of that. So I wouldn't say if I have a mole of nitrogen gas, I wouldn't say that I have 6.02 times 10 to the 23rd atoms of nitrogen gas. I would say I have 6.02 times 10 to the 23rd molecules of nitrogen gas. We have to use the correct representative particle, which represents that whole species in its simplest form, basically. So why do we use this mole in chemistry? Why is this so important? The reason is because the atoms are so tiny. So tiny that a mole of atoms will actually fit in the palm of your hand. So even though that's a huge number, we're talking about 6.02 times 10 to the 23rd, it doesn't matter that it's that huge so much when we're talking about atoms, because when you get that many atoms, it actually becomes a visible quantity. So here are some examples. Here is a mole of lead atoms, and here's a mole of copper atoms. Here's a mole of sodium chloride, and a mole of sulfur, mole of mercury, and here's a mole of water molecules, and here's a mole of sugar molecules. So in each of these, there are contained 6.02 times 10 to the 23rd either molecules or atoms. But so we need to use this because atoms are so tiny that we need to have a mole of them in order to be able to visualize what we're referring to, basically. And that is essentially it for what is the mole. You can watch our other videos on what molar volume is and what molar mass is and other aspects of the mole if you need to learn more. Thanks for watching. Remember, chemistry is everywhere.